So I to P transducer stands for current to pneumatic. I is current, P is pneumatic. The point of an I to P transducer typically is to relay our signals from our control room to our field devices. The reason for doing this is because it is much simpler to send an electric signal long distances than a pneumatic signal. Some devices, though, are only compatible with pneumatic signals, which is why we need to use them. But from the control room, we're going to be sending an instantaneous 4 to 20 milliamp signal. So here is a schematic of an I to P transducer. Coming in here, we have our facility instrument air header. Typically, that runs at about anywhere from 50 to 100 psi. But we need to drop down that air pressure to our device to a usable pressure. Otherwise, we can damage our device. Typically, this will be set to 20 psi. Also coming in, we have our control room signal, our 4 to 20 milliamp signal right here. So these are our two inputs, and then from this 4 to 20 signal, we can throttle our air supply to our 3 to 15 psi out. So here are our typical values, our 5 points. At 0%, we're going to be receiving 4 milliamps and outputting 3 psi. At 25%, we'll be inputting 8 milliamps and outputting 6 psi. At 100%, we'll be inputting 20 milliamps and outputting 15 psi, and so on and so forth. So here's some of the typical errors we can expect to see with I to P transducers. The first type is called zero shift error. So when we have a zero shift in any device, it is an error that is consistent throughout the entire range of values of our input and output values. So for a typical I to P transducer, we input 4 milliamps. We're expected to receive 3 psi on our output, but instead we're at 3.5 psi. So we have a zero shift of 0.5 psi above our expected value. And you can see this error consistent throughout our entire range of values. So at 9 psi, we're actually at 9.5 psi. At 20 or at 15 psi, we're actually at 15.5 psi, and that's represented here in this chart. The red represents our expected, the blue represents our actual when we have a zero shift error. The next common type of error we can expect to see is span shift error. And span shift error begins at an acceptable starting point, and it diverges from our expected value, and the error increases throughout the range, our total range. So it begins at an acceptable value. At 4 milliamps in, we're expecting 3 psi out, and we do have 3 psi out. But as the values increase, the error gets larger. So you can expect to see a 0.25 psi increase throughout the entire range, all the way ending at 16 psi, which is far out of tolerance. Demonstrated by this graph right here. The red again is our expected, the blue is our actual measured, okay? The next type of error we can expect is non-linearity. In this type of error, we begin and end at acceptable values, but towards the middle, we verge out. Demonstrated by this graph right here. The red is our expected, the blue is our actual measured. At the bottom and top, we have acceptable values. In the middle, it bows out like this. With this kind of error, there is no fixing it with an I to P transducer. There is no linearity adjustment on an I to P. So if this type of error is beyond an acceptable range, then the device is no good and it needs to be replaced. So we're going to do a simple I to P calibration, and here is a schematic drawing of our calibration test equipment. So we're going to, like any situation, have a regulated air supply coming in. Here's our regulator, here's our air supply coming in. We're going to have 3 to 15 psi coming out, of course, as always. And we're going to have this piece of test equipment right here, our fluke, source our 4 to 20 milliamps in. So coming out of positive of the fluke goes to the positive of the I to P. Negative from the fluke goes to the negative terminal on the I to P transducer. And we're going to tee off to this module right here, which converts the pneumatic signal to a digital signal, which is readable by our fluke. Our fluke will then display our values, our sourcing milliamps, and our measured 3 to 15 psi receiving end. Okay, so let's take it over to the actual device now itself.